Okay, so you have learned now the elementary rule of differentiation, and you have learned the product rule of differentiation, and now the quotient rule. The quotient rule is similar to the product rule, except we're finding we're going to be dividing the factors. So for example, here we've got the function called capital F, and we've got a factor f being divided by a factor g with a different color. We see then, in order to find the derivative of this division function, we will take the derivative of f, multiply it by the derivative of g. We multiply it by just g, not the derivative. Subtract it by the derivative of g multiplied by f, which is similar to the product rule, except here we're subtracting. Product rule, there was addition right there. And then, lastly, this is all divided by the square of g. Okay, let's try some examples. Looking at example 1 here, some people find it very helpful at the beginning of a question to simply write down f and g. So a lot of people will do this. F is equal to, in this case, 2x. We see the numerator. And the derivative of f then, if I look here, the derivative of that is 2. Also, g is x minus 3, and the derivative of g then would be 1. So finding that and identifying that, this lets you then plug it into the formula. This is going to be handy when we get to the chain rule, for example, in 4.8, also 4.9 and 4.10, where we need to define the parts of the original function and their derivative. So now we can just, y prime is equal to f prime, 2, times g, x minus 3, subtract g prime, 1, times f, all over g squared. And if I then do the work, cancels out, and we're left with negative 6 over x minus 3 squared. Okay, so by defining this here, then, we can simply plug it in and find our answer. So flipping the page then, I've already defined the parts of the function. I've written down f, that's the numerator. I've found the derivative of f. I've written down g, the denominator, and found the derivative of g. So then, simply, if we are finding f prime of x, it is the derivative of f times, here, times g, subtract the derivative of g times f, all over g squared. And when we multiply that out and simplify it, we get minus 5 over x minus 1 squared. Okay, similarly f, I would like you to pause the video and write out these definitions for number 3. Okay, go ahead. So then when we find f prime of x, we've got derivative of f times g, that'll equal 0. Subtract the derivative of g times f, all over g squared. 0 minus 2 will be minus 2 over here. Now there's a lot of 2's. It does look like something can be reduced. Let's take a look at that. So the denominator here, this whole part is squared. So if I want to factor out a 2 from that binomial, I'll have that. Everything is squared. Okay? And let's see if I can get a 2 out of there. So if this squared is onto both parts, right? So this is actually 4 times x plus 2 squared. And there we go. We can see that reduces. 2 goes into both 2 and 4. So that'll be a negative 1 over 2x plus 2 squared. Okay, flip the page. Rather, just move down your page. Okay, so here's number 4. You can try this one on your own, exact same steps. We've identified the f and the g and found their derivatives, plugged it into the formula, and simplified it. Again, this is the derivative of f of x. This is the equation to find the slope of the tangent line to that function. Okay, let's look at 5. Okay, write small for number 5 because it's a long question and you've got very little room. Okay, so we've rewritten the question here with this radical sign given as an exponent, and then we can identify the f and write f prime, identify the g and write the derivative of g. Then we can use the product rule to find y prime. Y prime is going to be equal to the derivative of f times g, subtract the derivative of g times f all over g squared. Okay, I'll give you a minute. You can pause it and multiply that all out, and we'll see if we can reduce it. Okay, so we multiplied everything through and gathered like terms, and a lot of different exponents here. It's okay, we'll take it slow and we can deal with it. So we've got to here, and it's not reduced all the way yet. What we need to do, and this is given to us here to take out a common factor. Remember factoring something like this in Unit 1, where we look at this last term and we want this last term to be a constant. So we take out everything here. So let's try it. Go back up here. Y prime is equal to, okay, let's take out the half x to the power of negative a half. Now, I'm also noticing this negative on the first term. It's always nice when the first term in brackets isn't a negative, so let's take a negative as well. When we do that, we're left with, well, it'll be positive. We're left with a 2, because if I multiply this negative a half times the 2, I'll get this negative 1. X to the power, and I need to add an exponent of 2 over 2 to here to get a half. And minus, now we took everything out there, so just the 1. All over 2x plus 1 squared. Looking pretty good. Okay, let's see if we can get rid of this negative exponent, and then everything will be looking lovely. Okay, it's a negative right here. We've got a 2, it's a half, so we've got a 2 in the denominator, and we've got this negative x to the power of a half. So the negative makes it come to the denominator, the half makes it a radical sign. The rest of the denominator that was there, and we've got the numerator. Whoops, that's supposed to be a negative. That looks good. And that's our final answer. Okay, flip the page. Find the equation of the tangent line in general form at the point x equals 1 and y equals a half. Okay, so we know that the slope of the tangent line comes from the derivative of f of x. So, we can see here that we're dealing with a quotient, and so we're going to use the quotient rule. So we've written down f, that's the numerator, f prime, the derivative of the numerator, g, the denominator, and g prime, the derivative of the denominator, and I've plugged it into our quotient rule here. Now, no need to reduce this and go to all that work. We know that the spot here, x is going to equal 1 and y equals a half. So let's find the derivative at 1. So everywhere we see an x, we're plugging in a 1, which is nice. One plus 1, this will be 2 squared at the bottom. Okay, so pause there and find your answer. Okay, when I put my 1 in for x, I get a 0 in the numerator and a 4 in the denominator. So the slope is 0. What do we know about a line with a slope of 0? It's horizontal. Right? Okay, so if we picture that, we're asked to find now the equation of this line in general form. So if we picture this here, here's x being 1, here's x half. At this point of f of x, I'm assuming from looking at this graph that it's, I don't know, maybe the graph comes something like this. It's a guess. And the horizontal line that is tangent to that graph at this point is exactly horizontal. So we can draw this line. This is the horizontal line. It has a slope of 0. Do we know the y-intercept? Well, yeah, it intercepts here at a half. When we're looking y equals mx plus b of this line, well, we know the slope is 0. And we can see that the b is a half, right? So the equation here, y equals, well, 0 times x is 1 at that point, but it doesn't matter. Y equals a half is the equation of that line. In general form, y subtract a half equals 0. Voila. Okay, so your assignment for this section is page 195, numbers 1 through 17. Again, make sure you're asking many questions. I feel like if we were in the classroom, you guys would have your hand up way more often than you're texting me. So don't get stuck if you have a question. And don't take another hour to try to figure it out. Feel free to text or email with questions at any time. All right, good luck with your assignment on 4.7.